So let's go through a demonstration of the tolerance analyst, TOL analyst. And this is part of SOLIDWORKS Premium, so you need to make sure you go into your add-ins and you go to TOL analyst to make sure that's turned on. And I'll just go ahead and grab my model here. So I have a small assembly. And you see I have one already done here where it's showing the nominal dimension that I'm interested in. I have a part that I purchase, a wheel that goes into this caster. It's a purchased component. I don't have any control over how that's built and how it's put together, or how it's purchased. I got to buy the 40 millimeter wide wheel. So what I do need to consider is the parts that go around it to make sure I have a proper fit. So you see I've already run a study for this. You'll notice in assembly mode the DIM Expert Manager becomes a tolerance analyst results manager. And I can show what the min and max are. Min 38.2, max 48.1. I can even tell to include my orientation tolerances, which would give me a different result. It would give me a plate of glass here. It might be hard to see on the projection here of where those parts would end up living. It will also give us the list of contributors to the error. So it's going to show us the dimensions on the parts that are the maximum contributor to error on the part, and it's this part right here. It's showing the symmetric tolerance. It's plus or minus 5. So I could increase the tolerance on that and just hit the recalculate button and see what happens. So now I have a different value now for my worst case. I also see my my worst case min and max and my statistical min and max. So let's go through building one of these. So you can have more than one study in a model, so I can say give me a new TOL analyst study. It will ask me for a measurement. So in this case I'm going to pick two flat surfaces like this and tell it it's going to read the nominal value for me. I could pick things that were cylindrical, shafts and things like that as well. Now it's telling me to figure out the assembly sequencing. So it's telling me to select the first part that you put together, and that's going to be the base plate here. It makes the other parts go transparent. And it shows you what the neighboring components are. Automatically it did that. And it's looking at the mating scheme. So I can say add the two neighbors next. And then it sees what the neighbors of the other components are. The bushing right here. And the, where's the axle component? It's hidden right now, the axle that goes in the middle. But I can pick this bushing, add that, and then the next bushing and add that. So that's the assembly order. 1, 2, 3, 4, 5. I'm not going to assemble the axle. Now it's giving me detailed instructions on the assembly sequence. Which faces are you going to apply first? And it's going to take its best guess. And you can move these, you can hover over these symbols here. It's showing you the coincident relation, or mate I should say, and the concentric mate here. So you can tell it which thing you're going to put in first. So I can say, oh yeah, I'm going to line this up first and hit the number 1. So I click on number 1 and that's the first face that's going to be slapped together. Then the next face I'm going to pick this back wall right here. So that's going to be item number 2. And then item number 3 to line up the holes. And you see they both go as 1, and I don't have to actually pick number 3 because it's guessed that automatically. It also puts a check mark in the tolerance assembly area for that axle support, telling you you've achieved full tolerance or full constraint setup. So I'll pick the next item here. You notice you can cycle right between them all. But I'll do the same thing for this one. I'll pick this one for number 1, this one for number 2, and number 3 is all set. Then I'll do the bushing. So I'll do, you just hover over these and it gives you the tooltip, the highlight on the screen dynamically right there. And these are all set. And that's all set. So you hit the next button in the wizard here at the top, and it's done. We have our tolerance stack-up analysis showing me the nominal, the worst case min and max, 3845 and 4155, and our statistical root sum of square calculation. And I can see if I look at the way I've dimensioned this dimension right here, the contributor is 19% of my error is this 40 millimeter dimension to this cut right here. Now this is where it's really cool. I can double click that. It brings me to the actual parts tolerance dimension. And maybe I can open that up, make it half a millimeter instead of 0.3 because my worst case isn't that bad. Now that updated the other, did it update the other cut too, if they're linked? Could, you know, if you had, you just update each side. And now hit the recalculate button and see what that gives you. Now we're at 3805, 4195. So if we had that much room to play with, we'd be okay. Then, including geometric tolerancing, that's where it really becomes quite powerful. Here I have the min and max here, root sum squared, min and max here as well. So if you have SOLIDWORKS Premium, you have this. You can export the results if you want to do further analysis on it. So if you are good with Excel, let me just save that file out. It will export an Excel file, giving you all the numbers. There they are.